out. So we'll kind of slow down a little bit because we're going to do a few things in here. One thing we are going to do is have another chance to earn a homework pass. So I did tell this class, right, because I had one student bring me batteries this morning, that you can bring me batteries, right? Was batteries the only thing I told this class? Okay, so you can bring me AAA batteries before Friday or by Friday and get a homework pass. Another thing we're going to do, and we'll talk about it, if you see on Friday, you see it says sing songs. So on Friday, we're going to talk about 2 formulas, and we're going to put it to music because we memorize things better when we sing it. And I can't sing, so I will embarrass myself completely, and I will sing for you on Friday. And then next week, I'm going to give you a chance to get up in front of the class and sing the songs. You don't have to. So if you're sitting here right now going, oh my goodness, I'm going to die, that's awful, I'm not coming to school ever again, you don't have to. But you will get a chance to memorize the formulas, get up here, sing the songs, and earn a homework pass. And there's 2 of them, so I'm going to give you a chance to earn 2 homework passes. That means if you sing both of them, you'll get 2. If you sing one, you get 1. But you have to sing it, you have to face the class, and I will let you do it in groups of 2 as long as you're both singing the words correctly. If one of you is messing up all the time, you'll have to keep starting over or you won't get your card. So make sure you choose your partner wisely. And you can't be a partner for somebody else and earn 2 more math cards. So you can only do it once. You can be a partner with someone else. So if Jordan wants to be the partner with everybody, he can do that, but he's only going to get 1 math card per song. Are we good with that? So I'm going to be tough on homework. I'm going to be tough about it being turned in on time. And on time is going to be before the bell rings. So from here on out, as you start coming into class, have your homework organized and ready, your name on your paper, and then you can just come up, grab the stapler, staple it, and stick it in the tray. That way it's ready to go. So if you have questions, be sure to ask those before class starts so that you're not waiting too late and then you don't have time to ask for help, okay? Also, let me remind you, when you get your homework back next class, if you've missed questions and you don't understand why you missed them, then you should call me, text me, come in before school. Eventually, you'll have Encore to come in during then too. But ask why you missed them so that they don't catch you on the test, okay? So we won't take a lot of time in class because we have so much to cover, meeting every other day to go over questions, but I will still be happy to answer any questions you have outside of class. Does that make sense? All right, so we're going to jump into 1-2. Today we're talking about using length and midpoints of a segment. We're going to save our constructions towards the end of the chapter, and we'll take a day where we get out the compass and the protractor and we do all the constructions for the chapter together so that we don't have to do them each day and get those supplies out. All right, lots of vocabulary. Again, how many words are you going to have on your vocab test? 50, and that's probably going to be next week. So be making that Quizlet little at a time, or flashcards, or whatever you like to use. So we're going to be talking about rulers. Rulers can be used to measure the distance between 2 points. A point corresponds to one and only one number. So the first day I drew a number line on the board and talked about how there was a point at 0 and a point at 1. Each of those points has one and only one number, and that number is called a coordinate. You've come from algebra, so in Algebra 1 you talked about the coordinate plane. The coordinate plane is how many dimensions? 2-dimensional, right? It's got an x-axis and a y-axis. It's like a plane, so it's 2-dimensional. We're going to start off really simple today, and we're talking 1-dimensional number lines. So we're baby math in here at the beginning. So a 1-dimensional number line talking about one coordinate on that number line. The ruler postulate is not a postulate that I would tell you go home and memorize. It is not super important. We won't use it in a proof later on in this class, but basically it's just reminding you that each of these points on your ruler has one and only one number assigned to it. So I have a point at 1. I have, oops, thought I fixed that. Let me go back. I worked on this last week, but maybe I didn't fix it. Okay, let's see if that works. So each of these points, there's exactly one number that corresponds to each of those points. And that's all this ruler postulate says. So to me, that's kind of common sense. Okay, we're going to talk about distance today in 1 dimension. And then on Friday, we're going to talk about distance in 2 dimensions. So again, this is just baby math on a number line. Definition for distance. The distance between any 2 points is the absolute value. What does absolute value do to a number? Makes it positive. So if I have the absolute value of -5, that's actually what? +5. So the distance between any 2 points will be the absolute value because distance will always be measured with a positive number. If you drive your car in reverse, you don't say I went -5 miles. It's still you went 5 miles in reverse. So it's the absolute value of the difference. What does difference mean to do? Subtract. So you're going to take the absolute value after you subtract the 2 coordinates. Some of these are going to go, I don't need to do that. That's so simple. But what they mean is if you have something really easy like this, let's say that this is at -2 and this point B is at 7. I can find the distance from A to B by simply taking the absolute value of the difference between these 2 coordinates. So I could say -2 minus 7. What's -2 minus 7? -9, but then the absolute value gives me what? +9. Or you could simply count on the number line. Sometimes those numbers are going to get large and you're not going to want to count every little tick mark. So you can just subtract the 2 numbers, take the absolute value. Okay? One thing I wrote there but I didn't explain. When you see 2 capital letters side by side, that means distance. Guess I didn't fix it. I'll work on that some more. Distance. 2 capital letters side by side means distance. So they may not write anything on the homework other than find AB. And it's 2 capital letters and there's nothing up above it. It's not a line segment, it's not a ray, it's not a line. It's just 2 capital letters side by side. They're telling you to find the numerical value of the distance between the 2 points. Okay? Sometimes they'll write it with the word length. The distance between A and B is also called the length of AB. And students get confused every year. Well, why did they put a line segment here but they didn't here? So here's what they'll do. They'll either write this, length of AB, and put a line segment above it, or they'll just do this. Okay, so they both mean the same thing. Length of AB means find the length of the line segment AB. And if you just put 2 capital letters side by side and don't put a line above it, it means find the distance from A to B. Okay, I'm going to be super picky about notation, so you don't put a line segment above it if you're telling me what its value is, unless you're writing the words length of in front of it. Otherwise, take off the line segment and just put 2 capital letters and give me the number. So really simple here. Again, you really don't have to subtract and take the absolute value if you can just count. So let's just say it out loud. What's the distance from B to C? 2. And again, notice the notation. They did not put a line segment above it. BC equals 2. What's the distance from A to C? 5. Again, you could show your work. Absolute value of -2 minus 3. So it's the difference between the 2 coordinates. And that gives us the absolute value of -5, which is 5. Everybody okay with that? Okay. This is just another example dealing with fractions. I'm going to skip it just for time purposes, but just another calculation finding the distance between 2 points. Okay, so now we're going to talk about congruent segments. Congruent segments are segments that have the same length. 2 segments that have the same length are congruent. They're going to use what are called tick marks on your pictures to indicate that they are congruent, that they have the same length. If they put one little mark and one little mark, if they have the same number of tick marks, that means they're congruent. If one of them has 1 mark and another one has 2 marks, then they're not the same length. Okay, so you'll be looking for those tick marks. Next thing that students struggle with all year long, and I will do my very best right here to indicate the difference, is notation when we're talking about shapes versus numbers. So I'm going to point this out up here. This says PQ equals RS. This says PQ is, and then there's this little symbol. That little symbol is an equal sign with a little squiggly above it. It's a congruent symbol. If you're using the word congruent, you're going to write this little symbol every time. It means congruent. So here's the thing that, again, we will be writing proofs, we'll be writing notation all the time, and it's so important that you're doing it correctly. So I want to make sure you're clear. This means distance, and you're going to put a number. This means the actual line segment shape. There's a difference. So if I'm saying PQ and RS have the same numerical value, they're both 3 inches long, then I would say that they are equal to each other. 3 inches equals 3 inches. If I'm saying this line segment looks the same as this line segment, then I say that they are congruent to each other. The shapes are congruent. So if I'm talking about the shape, the line segment, I use the congruent symbol, I put a line above them. If I'm talking about the number value, I take off the line and I use an equal sign. You may look at me thinking, okay, we got it, it's no big deal. It catches you every year I have students who keep making that mistake. So you put a line segment above it if you're talking about the shape. If you're telling me the value of it, you do not put a line segment above it. Distance is just 2 capital letters side by side. Okay. Again, we're going to do our constructions next, probably next week. And that's when we'll get the compass, the protractor, and do our constructions. And actually, we'll just use a compass and a straight edge. We won't use a protractor. But a construction is a way of creating a figure that is more precise. And one way to make a construction is to use a compass and a straight edge. We'll call it a straight edge. We'll use a ruler, but you won't be allowed to use the actual numbers on the ruler. So you'll just be using it so that you can make a straight line. You won't be using a ruler to measure with. You'll use the compass in order to do all the measuring when you're doing a construction. Okay, the next word that they give us is the word between. And between, it's just kind of weird. All I really need for you to understand is what they mean when they say between. If they say point B is between 2 points A and C, that means I could have a point here A, I could have a point here C, and B is anywhere in between there. B could be way over here, close to A. B could be in the middle. B may be closer to C. Between does not mean in the middle. It does not mean midpoint. So just be really careful. In order for you to say that point B is between 2 points, all 3 points have to lie on the same line. So A, B, and C would be on the same line. But between does not mean at the middle. What it does mean is our very first very important postulate. I'm going to stop real quick because you guys don't have textbooks yet, but I'm going to show you something really important once you get your textbooks. And you juniors are going to get them tomorrow. Sophomores are going to get them on Wednesday, and freshmen on Thursday, hopefully, if it goes as quick as they think it will. Okay, when you get your book, first of all, in the back, there are all these little colored tabs that are going to be back here. Some are green, some are kind of a teal color, some are purple or red, so different sections in the back of your book. I'm going to take us to this little teal section. I'm going to show you here with my book. This is where they're going to list all of the postulates and theorems. If you remember last Thursday, we learned 5 postulates. Do you guys remember that on the homework? So they are already listed right here. This is chapter 1 in the teal section of your book. And they've already got the first 5 postulates we've talked about. We're going to learn more postulates and we're going to learn theorems. Again, geometry is like a foreign language. You're going to have a ton of vocab, you're going to have a ton of postulates, you're going to have a ton of theorems. And you've got to memorize most of those as far as not word for word to be able to write them out, but to use them on your homework, okay? So the very first one that we talked about today was the ruler postulate. Not super important. Don't stress about that one. This next one, very important. The segment addition postulate we will use all year long. Very important. So you're going to find these divided by chapter at the back of the book. I wanted to point those out to you so that when you're studying for the test, you can look back here instead of having to scan through all your notes if you don't want to, and find the list of postulates and theorems and kind of study right here. And then as we go, this will be chapter 2 and then chapter 3, and you'll see that there start to become more and more postulates and theorems, but that'll also be when we start to lower how many definitions we're learning. So we'll have less definitions, more postulates and theorems. Okay, so segment addition postulate. Again, your postulates are kind of common sense. So see if this makes sense to you. This means the distance from A to B. This is the distance from B to C. If I go from A to B and then B to C, should that be the same as the total distance from A to C? Yes. So it'd be like me driving to Tawnytown, stopping at the stoplight, and then driving on to Springdale. That's the same as just going straight to Springdale. Sorry, I got it. So talk amongst yourselves. Give me just a minute. Okay. So everybody with me? The little part plus the other part should equal the whole. Part plus part equals whole. That's the segment addition postulate. I'm going to probably say over and over in just general terms, part plus part should equal the whole. But mathematically, the way they're going to ask you to write it on your homework is like this. They're going to ask you to write distance plus distance equals whole distance. So AB plus BC equals AC. I think there's one question on the homework that says, write the segment addition postulate for this situation. And all they're wanting you to do is this. Distance from one point to the next plus distance from that point to the last is equal to the whole distance. So don't make it harder than it is. It's just writing this equation right here. Remember, there's no lines above these because we're talking about distance, not the actual line segment. Any questions there? Okay, now we're going to throw in some algebra. So you'll have some simple problems like this, and notice there's no picture. A lot of times you have to draw yourself a picture. They'll start off really simple, which is basic numbers, and then they'll throw in algebraic expressions. So G is between F and H. That means on my paper I could draw F. I forgot to quit clicking the board, sorry. H, and then I can put G somewhere between F and H. And I don't know for sure where G is, I just know it's somewhere in between F and H. They tell me that the distance from F to G is 6, so I can label that on my picture. They also tell me the distance from F to H, this whole distance, is 11. The question is, what's the distance from G to H? So what would the distance from G to H be? 5. Okay, very good. In your mind, you just did 11 minus 6, right? If, as these get harder and you have algebraic expressions, you could write out the segment addition postulate. FG okay. FG plus GH equals FH. So you could write that out and then plug it in. FG was 6, GH is X, we don't know what it is, or in geometry, we'll just leave it as GH equals 11, and then we'll solve that equation. What would I do to solve that equation? Just subtract 6. So I would subtract 6 from both sides, and GH is equal to 5. When you write your answer, do not put a line segment above it. I'm going to keep reiterating that. You're giving me the number, not the shape. Okay, so here's one with some algebra. Go ahead, see if you could write this down right now. What would the equation look like? It says M is between N and O, and ultimately we want to find NO. So write on your paper what you think the equation would look like to start to solve it. Raise your hand if you know what the equation would look like to write down just to start to solve it. You have an idea what to write on your paper. Go ahead, Jason, what did you write down? Very good. So this is where we start. NM plus MO equals NO, and then we can plug in what we know. What is NM? 17. What's MO? 3x minus 5. And what is NO? 5x plus 2. And now you have an algebraic equation, and this is why you had to take Algebra 1 before you took geometry, and now you need to solve it. So, what would you want to do first to solve it? So, go ahead. Okay, so I could go ahead and simplify what's on the left-hand side first. So what is 17 minus 5? 12. So now I have 12 plus 3x equals 5x plus 2. Now what do you want to do? Okay, I heard subtract 2. I heard somebody else say. Okay, I probably wouldn't start plugging in numbers to try to solve because you don't have any idea what you're going to get, and you can end up with fractions, you could end up with decimals. So plug and chug is not going to be your best option to try to work backwards. So let's use our opposite operations to get x by itself, because our ultimate goal is to find out what is x. So I could subtract 2. What else could I do? I could subtract 3x. It doesn't matter, whatever you want to do. I'm going to start and subtract 2 because I heard that first. So what's 12 minus 2? 10. Plus 3x equals 5x. So now what do we need to do? Subtract 3x. So we're combining like terms by moving them to the other side of the equation using opposite operations. So now we end up with 10 equals what? 2x. So what do we do now? Divide by 2. And what is x? 5. But again, you may end up with some ugly numbers. You may end up with fractions, decimals. So just be aware. That's why we're practicing those skills on that proficiency test. Is this my answer? No. What did it ask me to find? NO. And again, that's the distance from N to O. So N to O was what? 5x plus 2. So we have to plug this in. So we're going to say NO equals 5x plus 2. Plug in your x of 5. So that we have 5 times 5 plus 2. What's 5 times 5? Plus 2. So our answer would be NO equals 27. And again, no line segment above it because we're talking about the numerical distance. Questions on segment addition postulate. You need to memorize that name, segment addition postulate, because you will use it in proofs later, and it means part plus part equals the whole. All right, next one. Oops. We have midpoint. So between does not mean midpoint. Midpoint means the very middle point, or the definition that we're going to use, and it's super important that you're memorizing the correct definition when we get to proofs. So the midpoint M of line segment AB is the point that bisects, we'll come back to bisects, or divides the segment into two congruent segments. The definition for midpoint is the point that divides a line segment into two congruent segments. So if I have a line segment here, AB, this point M is the midpoint if it splits the line segment into two congruent pieces. Notice the little tick marks are showing you that they're congruent. So we would say, with correct notation, AM is congruent to MB, or BM, it doesn't matter how you name a line segment. Or we would say the distance from A to M is equal to the distance from M to B. So again, notice the difference in the notation. Bisects means to divide a segment into two congruent parts. So the midpoint is the point that is bisecting the line segment. Okay? So before we do this example, I want to show you an extra example that's not in your notes but will be on your homework. So somewhere on your paper, write this down. M is the midpoint of AB. I'm pretty sure I didn't give you any like this. Guys, here it gets real fast. Oh, I lied. There is one on your notes. Don't write that down. I'm going to skip ahead. I did put one on your notes. I forgot. So we're going to come back to this example in a second. So I'm going to skip it real quick. Oops, and go to this one. So go all the way to this example in your notes. Is this the last example in this section? No. Okay. One more? All right. So notice the directions here. D is the midpoint of EF. So if D is the midpoint, what could we draw on our line segment to show that D is the midpoint? Little tick marks. We could put a tick mark here and a tick mark here to show that those two distances are the same, that they are congruent line segments. Okay, then they tell us that ED is 4x plus 6 and that DF is 7x minus 9. If these are congruent, what does that mean about this expression compared to this expression? They're equal. So this is a situation where you would not do part plus part equals the whole. For one reason, do they tell us what EF is? No. So if I did part plus part, I would be stuck because I don't have anything to set it equal to solve. But because they told me D was the midpoint, I don't need to know the whole thing. I can just set these two expressions equal to each other. Bless you. So 4x plus 6 equals 7x minus 9, and then I could solve that simple algebra equation. Do you see the difference of when you can set them equal and when you have to add them? Okay, so if I set them equal, now we're going to solve. What do you want to do? So, what did you say? What did you say? Plus 9? Okay, did you guys say the same thing? Okay. All right, so if we add 9, we have 4x equals, 4x plus what? Plus 15 equals what? 7x. From here, what do you want to do? Minus 4x. And then we get 15 equals 3x. And so what is x? 5 by dividing by 3. Is that my answer? Did they just say find x? No, be very careful. This one wants you to find ED, DF, and EF. So now you have 3 things to find. ED is 4x plus 6. Plug your 5 in. 4 times 5 plus 6. What's 4 times 5 plus 6? 26. Now, save yourself some time. If ED is 26, what is DF? 26, because we said they were the same. So you don't have to show your work there. You can just circle your answer there, 26. And if ED is 26 and DF is 26, then what's the whole thing EF going to be? Good. 2 times 26, which it is? 52. And again, no line segments above those when we're telling what they're equal to. Questions if we know the midpoint versus segment addition? All right, I'm going to go back. I want you to take a few minutes with your partner and I want you to work through this example on your own. I'm going to give you a few minutes to see if you can get the correct answer. Before we start, every year I have students who get confused, so I'm going to go ahead and just brainstorm together real fast and just to point out, this is in feet, this is in miles. So you're going to have to do some conversions. How many feet are in a mile? You guys are so smart. So in 1 mile, I just heard you say there are 5,280 feet. So keep that in mind as you're working through this problem. Okay? Take a few minutes, work on it. Word a while ago, that little last example. So if you're just now watching the video, I did not go over that last example in the video. Look at the filled-in notes that I sent out to you. Okay. So take just a minute with your partner, read through this example, and see if you can answer it. Again, you're not going to get a calculator, so keep doing your math by hand. You'll be all right. Okay, so first of all, if I'm taking an ACT timed test, one thing I would want to do is try to do process of elimination, right? So if it's the 7th term, based on the pattern you see, is it going to be a positive number or a negative number? Positive. So that already rules out which 2 choices. Okay? Does everybody see that? We're going from positive to negative, so the even terms are negative, so the odd terms are going to be positive. Since it's 7, that's an odd term, it's going to have to be positive. So now we have a 33% chance of guessing correctly versus a 20% chance. So we've raised our chances. What's happening every time in this sequence? Multiplying by -3. So I'm going to take -27. Oh, I did not fix it. I keep thinking I've got it fixed over here, but then it keeps messing up. Somehow I've got to save the fact that I've clicked this. It does not want to save it. Try this again. Okay. So -27, we're going to multiply by -3. That's going to give us a positive what? 81. Then we're going to multiply by -3 again, and we're going to get a negative what? -243. So right now, I already know it has to be what? Larger than 243, so that rules out C and D. So what's the answer? E. Process of elimination, save yourself time. Do you really have to go and multiply by -3 again to get the answer? No. And so when you're taking those timed ACT tests, and if time is an issue for you, then try to find quick ways to go ahead and get the answer and move on. Don't be so structured that you're used to your teacher, like I will be this year, that makes you show all your work and circle your final answer. You don't have to do that on a timed ACT test. You just need to get the answer as quick as you can and move on. Okay? We're going to be talking about sequences coming up in this next chapter. So I wanted to throw this up there just to kind of give you a little practice. If I multiply that by -3, I would get positive 729. And again, this is an old released item from the ACT, so real questions that you'll see. Okay, so now we're going to move to our angles. And these are all the vocabulary words we're going to try to get through on our angles. And I'm going to kind of just skip over this first part. This is just kind of FYI. They're going to try to get you to understand some word problems and relate this section to the concept of surveying. And if you're doing surveys, oftentimes you use a little transit tool. How many of you have ever seen a transit tool? Okay, so that's totally new to you. A transit is just a tool that they use to be able to shoot kind of like a laser out to measure the height of something or the distance of something. So they'll use that a lot over in the CAST building. They'll probably use transit tools. If you see surveyors out trying to survey the land, they'll use a transit tool. So this is just a little information about a transit tool. What we're going to do in this section is talk about angles. So we might, in our word problem, have a transit tool that's measuring the distance over to this point and the distance over to this point, and now all of a sudden we have a picture of an angle. Does that make sense? With one exception in here, when we draw angles, we will always draw them as two rays connected together. Arrows have to be on the end, so I'll be really picky about that because that's the definition of an angle. An angle is a figure formed by two rays. Sometimes in the book, they don't put arrows, and that's a mistake. It should have arrows on the ends, okay? So an angle is a figure formed by two rays or sides. We're going to call these the sides of the angle. And they have a common endpoint, which is called the vertex. So this vertex point here, I'm going to label A. You do not say vertexes. What's the plural form of vertex? Vertices, so make sure you're saying that correctly. You can name an angle several ways. So remember we talked about yesterday how to name, or not yesterday, but last week how to name points, lines, planes, segments, rays, and all the notation is super important. You can name angles several different ways. So I'm going to talk to you about how you can name angles. So let's start with this picture of an angle right here. And I'll get to the stuff on the top in a minute. One way you can name an angle is by just using the vertex and an angle symbol. So we can call this angle angle R. That's one way. By just using the vertex, angle R. There is a difference between an angle symbol and a less than symbol. And I won't be super picky, but I had a professor in college who was. So we would get counted off if we did this. Oops. If I wrote angle R like that, I would get counted off. You can barely see that. Some use a different color. It's supposed to be flat on the bottom, whereas a less than symbol looks like that. Okay? I won't be super picky about that, so don't stress, but it should be flat on the bottom. So angle R is one way. You can only name it by its vertex if it's the only angle in the picture. So this is not the best way to name an angle. If you have a picture like this, how many angles are in that picture? 3. There's actually 3. There is this angle, I'm going to name it 1. This angle is 2, and then there's the great big angle, which would be a third angle, right? So if you say angle R, are you identifying which one of those you're talking about? No. So if there's more than one angle in the picture, you cannot name it by its vertex. Instead, you have to use 3 letters. SRT. The middle letter has to be the vertex. So I could call this angle SRT as long as R is the letter in the middle. It tells you the direction to draw it. Start at S, go to R, then go to T to make your angle. Or you could call it angle TRS, T to R to S. Still talking about the same angle. Everybody okay with that? Or if there's a number written inside the angle, do not add it to your pictures, but if they've given you a number inside your angle, you can name it by that number. That's not the measure of the angle. It's not a 1-degree angle, it's just a way to name it. Angle 1 or angle 2. Everybody clear there? Okay, notice every one of these has an angle symbol in front of it. You have to have an angle symbol. If you think about interior, what do you think of? Inside, exterior, outside. So the interior of an angle is the set of all points between the sides of the angle or all the points inside. Can't tap my screen. I don't know why I just did that. Exterior of an angle is the set of all points outside the angle. So that's going to be these points out here. Out here. Is S considered interior or exterior or neither? Neither. It's actually on the angle. So interior means inside, exterior means outside. S, R, and T would be on your angle. Okay, so let's see if you can name some angles, and I'm going to call on you and start memorizing names. So let's go with Molly in the back. Molly, can you name one angle in this picture? Angle 1. All right, let's go with Lucas, can you name angle 1 a different way? So the same angle but a different way. Very good. Angle RTQ. And then Luke, can you name that same angle a different way? Very good. Angle QTR. Can we name that angle angle T? No. All right. Let's go with Zach. Can you name a different angle? Angle 2. And let's go up here on the front. Jocelyn, I had your sister as well, did I not? Yes. Can you name angle 2 a different way? Angle RTS. And then next to Jocelyn, I've got Madison. Can you name that same angle a different way? Angle STR. And then we have one angle left in the picture we haven't named. Who can name it for me? Go for it back here. Angle QTS. Is that the only way you could have named that? No. How else could I have named it? Angle STQ. Very good. All right. And it's, you want me to call you Yee, right? All right, Yee. Any questions? Okay, naming angles. Hope you can name them correctly. Okay, we're going to measure angles. I gave you a protractor. I want to talk about making sure you know how to measure an angle with your protractor. So just a couple of things in case you haven't used one in a while. There's a little center spot here where you're going to be putting your protractor on your angle. Where is that protractor going to go? I mean, where's that little dot going to line up with? The vertex. Then you'll notice there's a blue line right here. That blue line is going to line up with one side of your angle, one of your rays of your angle. When you read with your protractor, depending on which protractor you have, make sure that when you line that up and you go to measure your angle, that you are starting at 0, not 180. So if I'm lining it up and I'm going around this direction to the right, then I'm going to read from the blue 0. But if I line it up over here on the right-hand side and I'm going to the left, then I'm going to read from 0 in the orange. Does that make sense? So right now, on your paper, draw yourself an angle, any angle. I'm going to draw one on the board, and then we're going to measure it. Everybody's will be different. So draw yourself an angle. Then look up here for a minute to make sure you understand how to measure. This little part in the middle is going to line up with my vertex. So I'm going to line that up. Then I'm going to line up where it says 0 on one side of my angle. So notice I have this ray. The center is on my vertex, and I have this line lined up with 0 on that ray. Everybody with me? So now as I read around, going to the left, I'm going to follow this ray up. I'm not going to read these top numbers because that's starting at 180. I'm going to read these closer numbers here to the left starting at 0. So my angle would be about 78 degrees. Does everybody agree with that? Not 98, but 78. Not 102 or whatever that looks like. Questions on how to measure with the protractor? Yes, sir. Through it. So then you might want to grab your ruler or extend your line out. So let's say that I had this like this, but really it was kind of like here, right? And I couldn't read where it's going through. You may want to line your ruler up then on that ray so that you can see exactly where it's crossing up here. Does that make sense, Canyon? Okay. Or extend your line on out. Okay, so we can use a protractor to measure. We will do that when it specifically tells us to measure. Most of the time we won't use a protractor. We'll do the algebra to actually solve for x and get our measurements of our angles. If you're measuring an angle in geometry, our angles are going to be measured in degrees. So you're going to be using this little degree symbol. However, that's not the only way you can measure an angle. It's kind of like a ruler. On the ruler, you have two different sides. One side is measured in what? Inches. The other side is measured in centimeters, and the little bitty ones are measured in millimeters. So on a ruler, you can measure a line in different measurements, right? With an angle, you can measure it in degrees or you can measure it in radians. Radians will be used in pre-cal a lot. So we'll talk about, if we have time, the difference between radians and degrees in here. But in geometry, we're not going to be measuring in radians. Everything will be measured in degrees, okay? If you think about a circle, how many degrees are in a circle? 360. If I were to divide my circle into 360 little angles, then that would give you what 1 degree is. 1 degree is 1/360th of a circle. So if you take a circle and divide it into 360 angles, that's what 1 degree is. Okay, the next part of the notes, and these will be on your vocab test, so these are vocabulary words all across here. You should already know these terms, but we'll review them. So an acute angle is an angle that measures what? Less than 90. But it is going to be a positive number, so it is greater than 0. So we would say that it is an angle that is, oops, let's go back. My angle is greater than 0, but less than 90 degrees. I'm trying to do good about showing that's a flat, and those are less than symbols. But it is between 0 and 90 degrees. A right angle is exactly 90 degrees, and notice the little right angle box. When you see that little box on your homework, that means it's 90 degrees. Obtuse is going to be greater than 90, but it's going to be less than 180, so it's going to be in between 90 and 180. So again, the angle will be greater than 90, but less than 180. Right, and then a straight angle looks exactly like what we talked about last class. What is that also an example of? Opposite rays, which are also an example of a line. So when you see a straight angle, you're also seeing a line and you're also seeing opposite rays. It just depends on what the context of the question is. Is it talking about it as an angle or is it talking about it as a line? So what is it referring to? A straight angle is always going to be exactly 180 degrees. Okay, so then, yes sir, sorry. Than 180. So we're not going to talk about angles in terms of being greater than 180. You will in pre-cal. Our angle measures, when we're measuring, we're going to keep them at 180 or less when we measure, okay? There will be some problems maybe where it says that it's greater than that, but most of the time we're talking about 180 or less in here, okay? So there's not a name. It's actually called a reflective angle, and so you'll learn more about that later, okay? All right, so go ahead right now and answer questions A and B based on the diagram given. You don't need your protractor. They've given you one. See if you can figure out those two angle measures. Oops. Okay, want to point out one thing real quick. You may still be looking and answering, but real quick, I didn't point this out and I need to, so make sure you are paying close attention right here. This is another notation thing that I don't want to count off for, but I will if you're not writing correctly. This is how you name an angle. Angle WXV. This is how you write what the answer for the measure is. This little m means measure of the angle. So you'll write that whenever you're telling me how many degrees it is. Okay? So if I look over at the picture, WXV, how many degrees was WXV? 30 degrees. Again, you're reading from 0 up, so 0 to 30. make sure you put your degree symbol when you do that. Any questions on measuring it? Okay, it said then classify. When it says classify, that's not the name. That's telling me, is it acute, right, obtuse, or straight? So what is this? Acute. To name it would be to write it like this. To classify it means to tell me what kind of angle is it. All right, B, what is the measure of ZXW? Okay, if I measure all the way over to here, this says 130, but am I starting from down here? No, I'm starting from up here, WXC, so I need to take away this angle, which is how much? 30. So what's 130 minus 30? 100. Again, if you were using your protractor, you would just turn your protractor and line it up with the XW, and that would be easier. So what kind of classification do we give this angle? Obtuse. All right, we're almost done. So the last thing here we want to talk about is congruent angles and how that applies. Same ideas as congruent segments. Congruent angles are angles that have the same measure. Again, you're going to use tick marks, but when they're angles, we call them arc marks because they'll be little curves or little arcs. If they have the same number of arc marks, 2 arcs, 1 arc, that means they're congruent. If they have a different number of arc marks, they are not congruent. So going back to that notation that I talked about over here a few minutes ago with segments, you can say PQ is congruent to RS, or you can say the distance from P to Q equals the distance from R to S. No line segments when you're using equals. Same idea with angles. You can either say the measure of angle ABC is equal to the measure of angle DEF, or you can say the angle shapes themselves are congruent. What's the difference? If I'm using an equal sign, what do I have to add? The little measure. Okay, I'm talking about the number, so the little measure, the little m. If I'm using the congruent symbol, do I put the little m? No, I'm naming the angle. This angle shape is congruent to this angle shape. Okay? All right, and then you can see in the picture where they've drawn those angles. So then we have the angle addition postulate. It is the same as the segment addition postulate. Segment addition said part plus part equals whole. Angle addition says the same thing. Part plus part should equal the whole, but now we're dealing with angles instead of segments, okay? So if you look at the picture, they tried to color coordinate this and then they messed up. PQS is not what they colored in blue. PQS is over here in red. And then what they colored in red, SQR, is actually over here in blue. So don't let that confuse you when you're looking up here. But the big idea is this little angle here plus this little angle here should equal the whole angle total. And again, if on your homework they say write the angle addition postulate for this picture, this is what they're talking about. The measure of one angle plus the measure of the other angle should equal the measure of the whole angle. Is that clear? So then we can use that just like we did with the segments to calculate missing measures. Some of them will be simple with numbers and some will require algebra. So let's do a simple one here real quick. If DEG, so is DEG angle 1, angle 2, or the great big angle? The great big angle. DEG means this whole angle. It is 115 degrees. DEF, is that angle 1, 2, or the great big angle? The 1. So we're saying this little angle inside here is 48 degrees. So notice I used a different number of marks when I was indicating which angle I'm talking about in my picture. So what am I going to need to do to find FEG? Just subtract. 115 minus 48 is how much? What's 15 minus 8? 7. What's 10 minus 4? 6. So it is 67 degrees. Okay, so we would say the measure of angle FEG with correct notation is 67 degrees. Questions there? Okay, same ideas with the segments. We can look at some with algebra. Before I do this, I'm going to throw an example up here real fast. We're not going to work all the way through it, but just tell me what I would do. If this angle is 2x plus 3, this angle is 4x plus 7, and the whole angle is 9x plus 3. What would I do to solve? Okay, so what would I write down as an equation using these algebra expressions? Okay, and you added things together, and that's totally fine, but I'm going to write it separate first. So you said 2x plus 3, this part, plus 4x plus 7, this part, should equal the whole thing, 9x plus 3. Is everybody with me? Using angle addition postulate, part plus part should equal the whole. And who answered me a while ago and said that? Bryson, very good. So he just combined like terms and said 6x plus 10 just to make it quicker. He went ahead and combined those. Any questions on how we would do that with angles? Okay, last thing in your notes is angle bisector. It's like a midpoint. If we're talking about a line segment, it's just a point. An angle bisector is not going to be a point, but it is going to be a ray that divides an angle into two congruent angles. Like a midpoint divides a segment into two congruent parts, an angle bisector is a ray that divides an angle into two congruent parts. So if you look at this picture, if they tell me that JK bisects angle LJM, they're telling me that it's splitting the angle into two congruent parts. So I can put tick marks here to show that these are the same measure. Is everybody with me there? So that means this angle measure is the same as this angle measure. And again, notation here, we're saying the two angles are congruent to each other. So if I look at this last example that you have in your notes, if KM bisects angle JKL, what does that mean about this little angle and this little angle? If KM bisects this angle, what's it doing to the angle? Splitting it into two congruent parts. So what does that mean about this angle and this angle? They're congruent. And what does congruent mean? Same measure. So if they tell me that JKM, find it up here, is 4x plus 6, and then they tell me MKL is 7x minus 12, what could we do to solve? Okay, if I do the angle addition postulate, part plus part, do I know what the whole is in this picture? No, they're not giving us the whole, so what could I do instead? Okay, because it bisected, only if you see that word bisects, that means that this expression and this expression should be equal. So I can say 4x plus 6 equals 7x minus 12. And then I could solve for x. To save time, I'm not going to go through and do the math there. Has anybody solved for x yet on your paper? Can you do it in your head real quick? What do you get for x? It should be 6. Is that going to be our answer here? No, we're going to plug it back into JKM, so we're going to plug it back in here. So 6 would go in here, and we would have 4 times 6 plus 6, which is 30 degrees. Don't forget, if you're measuring angles, it's in degrees. I went through that pretty quick. Make sure you're with me. Bisect means to split into two congruent parts, so you can set them equal. If it doesn't say bisect, then you're doing part plus part equals whole. Questions today? We covered a lot of information. Okay, here's your second assignment, and just to make sure you're clear, you're only doing the problems on this little salmon piece of paper that's your assignment, okay? I had to photocopy the textbook because we don't have them yet, but you're not doing the whole worksheets, okay? And there's no core math tonight for homework, just what's on this little piece of paper. Core math was hard? Is that what you said? It's harder. The regular geometry class does not get a core math book. I reserve that fun just for you guys.